Hi everyone, welcome back to Math with Sami. In today's lesson, we are diving into the binomial expansion theorem, a powerful tool in algebra that helps us expand expressions like a plus b to the power of n quickly and efficiently. I'll walk you through the formula, step-by-step examples, and even some trick using Pascal triangles. By the end of this video, you'll be able to expand binomials like a pro. Let's get started. So here's the first question. Find the third term of this expansion. So let's identify our variables here, the a, b, and n and k. So a here will be 3x, b will be 2y, n is the exponent in here, which is 9. K is what you need to determine. So if they want you to find the third term, as you see, it reads tk plus 1. For this to read third term, then you have to make k2, because then if you make k2, then this t2 plus 1, that makes it t3. So now, since we identified all our terms, we go ahead and go t2 plus 1 equals n, which is 9, choose 2, a, which is 3x, to the a minus k, so 9 minus 2, and then b, which is 2y, to the k, which is 2. Now, 9 choose 2. So this will give me 36 for 9 choose 2. And then 3, that's going to be to the power of 7. So 3 to the power of 7 is 2187. And that's going to be x to the 7. And 2 squared is 4. And the y also will have the square. Now, times 4 times 36. So this expansion, or the third term here, would be 314,928 x to the 7 y squared. So here, this is another question that has a little bit of twist to it. They say, and find the middle term. Now you have to determine which one is the middle term. When n is 6, if you want to know the number of terms, you always go n plus 1. So therefore, n is 6 plus 1. So you have 7 terms altogether. And therefore, the middle term will be right smack in the middle, which is the fourth term. So here you'll be finding the fourth term. And if you want to find, so it's the fourth term that we're looking for. And to find the fourth term right away, you have to make k 3, because you remember this reads k plus 1. If you make k 3, 3 plus 1 is 4. That will read t4. And a here is 2. B, make sure you include the negative there, negative x over 2. And n is 6. So therefore, we're going to find t3 plus 1, n, which is 6 here, choose 3, and then a, which is 2 to the power of 6 minus 3, and b, which is negative x over 2 to the power of k, which is 3. Now, this becomes 2 to the 3, which gives you 8. And this here, make sure you distribute the exponent onto the x and into the 2. So x is going to give you x cubed. And the 2 is going to be 2 to the 3, which is 8. Okay. And then 6 choose 3. Is 20. So basically you have 20 times 8 times negative x over 8, negative x cubed over 8. Therefore, the 8's here will cancel. And the fourth term, or the middle term, which is t4 here, will be negative 20 x cubed. So here's one of the challenging questions that I told you about. And the challenge here is they want you to find the constant term. The constant term means that the term that doesn't have a variable, doesn't have axis in this case right here. We know a is 2x, we know b is 1 over x cubed, we know n is 8. Now, how are we going to find out what k is? That's the key. Constant term means no variables, so you want the variables to go. So there are two ways I'm going to show you how to do this. The first one, just by eyeballing this, so you know a is 2x and you know b is 1 over x cubed. And here you have n minus k, and here you have k. Now, always know these two exponents, they always end up adding to 8. So whatever n minus k and k is, when you add them, they end up adding to 8. So let's look at 2x. I'm going to just explore options, so we know that this and this have to add up to 8. So let's say if we make k 3 here, then this would be 5. And as you see, x is going to end up being to the 5, and here x is going to end up being to the 9. So that's not going to work. So I'm going to explore the next thing, 1 over x cubed. And I'm going to use 2 for k. And this is 2x. And 8 minus 2 is going to be 6. And as I told you that the exponents here and there, they always have to add up to n, the 8. So this will be 6 right here. Now, right away, see x here is going to be x to the 6, and x cubed here is going to be x to the 6 because of the square there. So since we have x to the 6 here, x to the 6 there, because this is a fraction, they're going to cancel, and I'm going to have no x's whatsoever. So right away, I know k is 2. Of course, a is my 2x, b is 1 over x cubed, and n equals 8. And so that's what the constant term is. This is the term that's going to have no variables. And let's explore that. So t2 plus 1, because k is 2, equals n, which is 8, choose 2, a, which is 2x, to the n minus k, so 8 minus 2, which is 6, and then 1 over x cubed to the power of k, which is 2. Now, 8 choose 2 gave me 28. And this will give me 2 to the power of 6. It's going to give me 64. X to the 6. And this 1 squared is just going to be 1. And x cubed squared is going to give me x to the 6. Now, as I said, the x to the 6 here will cancel with the x to the 6 here. And therefore, final answer is 28 times 64, which is 1,792. So basically, when you do this expansion right here, all of them will have x's except for the third term, because k2, that means it's the third term, k2 plus 1 there. The third term will end up just being 1,792 with no variables. Also, you'll hear that it's called the independent term. So independent term or constant term, that's how they ask it. The other approach is, it's going to get rid of this. So the other approach is you write b as x to the negative 3. Okay. Now you plug in things in the expansion there. So tk plus 1 equals 8, choose k, a, which is 2x to the 8 minus k, and b, which is x to the negative 3 to the power of k, because b has to be to the power of k. Now, a constant term, that means x will have to have 0 on top of it, because x to the 0 equals 1, and therefore that will end up giving you a constant term. So now I know, because this x here has no exponent, and we could just ignore that. You know what? We could just ignore the x, the 2 there, because we're interested in getting rid of getting a 0 exponent on the x. So here we'll have x to the power of 8 minus k, and this will be x to the power of negative 3k. So here, when you multiply these, you're going to get x to the power of 8 minus k, and you add that negative 3k as well. And therefore, you remember said the exponent has to be 0. So therefore, 8 minus k minus 3k should equal 0. Now, 8 should equal 4k, because that's negative k minus 3k is negative 4k. When you move to the other side, it becomes 4k, and therefore k equals 2. So that's the other way of doing it. Like determining k is key for this question. If you like eyeballing like I do, and just play around with the exponents here till you find out what k is, that's fine. And that way you could find k as well. And then you just find since k is 2, then we know we're interested in finding the third term, and I did that already for you, finding that term. Okay. So here's the last question I'm going to do in this here. So basically they're saying if this expansion has 18 terms, what's the value of n? So now you remember earlier I said to know how many terms you have, you always add 1 to this. Okay. So then 2n plus 3, when you add 1 to this, you get the number of terms which are 18. Okay. So again, if you have x plus 2 squared and you take this and FOIL it, you end up with x squared plus 4x plus 4. So that's 3 terms, and that's why you always, if this is 2, then you'll end up with 3 terms. So the number of terms is always the exponent here, which is n plus 1. So n plus 1 gives you the number of terms in the expansion. Yeah. Now, this is your n. Don't worry about the n here. I'm talking. This is your n according to this formula here. Okay. Right there. Okay. So this is your n. Therefore, n plus 1 should equal 18. And since n here is represented by 2n plus 3, then plus 1 equals 18. Now 2n plus 4 equals 18. 2n equals 14, and therefore n would equal 7. And as you see, if I sub in 7 there, that's 2 plus 2 times 7 is 14, plus 3 is 17. If you have n as 17, then you know you have 18 terms, because always it's n plus 1. That's how many terms you have. And that's all I'm going to do for the binomial theorem. As always, thank you for watching. Till next time, bye-bye.